KP classes dedicated to excellence.
So in today's class, now we are going to quickly summarize each and everything that we have done in the logical reasoning and quantitative aptitude. Now, whatever topics we are going to discuss in today's class, we are going to look into the logical reasoning, and the subjects that we are going to cover are given like this. We are going to completely cover this topic of block, coding and decoding, order and ranking, water image and mirror image. Then after that, your special aptitude that covers your cutting, folding, rotation, scaling, and all of that. So we will be only and only will be talking about the concept that are with these topics, and then after that, we will be solving some of the basic level questions that are being asked in the examination. So we are going to summarize all these topics in an exam oriented manner. Now I hope you guys have already gone through the 51-day course. There these topics are covered in a very detailed manner. There you have gone through the clock, coding, decoding, order, ranking, mirror image, water image, cutting, folding. And then after that, if I'm going to talk about the quantitative aptitude, this number system, mensuration, time and work percentage, all of that is being covered in the detailed manner there in that course. But this is a complete revision class. This is a complete revision of all these concepts that you have already done. So now we are going to start with the quantitative aptitude. So here we are going to start with the first topic, that is going to be your number system. Then after that we will discuss the concept that are involved in the mensuration. Then after that I'll be talking about the speed, distance and time. What are the formulas that we need to keep in mind? And then after that we'll discuss the concept of percentage. So now when I'm going to talk about number system, we need to understand in the number system what are the things that we need to understand. So if I'm going to talk about number system, there are three things that we'll be talking about. The first is going to be classification of numbers. That means we need to have the basic idea about what type of numbers are there. Like for an example, if I talk about there are rational number, irrational number, then after that your even numbers, odd numbers, composite numbers, prime numbers. So we need to understand the classification of numbers, and then after that we'll be understanding what type of questions can be asked from this part. So this is the first topic that we'll be having discussion on. This is going to be the classification of number. And then after that, the second thing is going to be your unit digit. And then after that, the third thing on which we'll be having discussion is going to be remainders. Remainders. All right. So this is the first part that we are going to talk about is going to be a classification of numbers. What types of numbers are there? You can make the short notes out of this. And in case you guys will be having any questions throughout the class, you can let me know in the chat box. If you want the revision of something, you can let me know in the chat box and we can do that. All right. So we are going to first start with this classification of numbers. So if we are going to talk about number system, this is something which is the foundation of the complete QA. We need to understand what types of numbers are there in which we'll be using in the arithmetic. Now these numbers are divided into two parts. This first type of number is called as what? These are the real numbers. Then after that, the second type of numbers are going to be what? Imaginary numbers. Now, in our exam, there are you will get no question on the imaginary numbers. You will be getting questions on the only and only real numbers. Now, these real numbers are what? These real numbers can be like, for an example, 1, 3, 5, 9, 3.09, 5.73. All these numbers are what? You can denote these numbers on the number line. So these type of numbers are called as what? Real number. Now, what is a number line? Number line is what? Like this. This is 0. This is 1. This is 2. This is 3. So if I'm saying 2.3976, you know that it will be somewhere here between 2 and 3. Now, if I say 3.9721, so you know that it will be somewhere between 3 and 4. So all these numbers which can be denoted on the number line are called as what? These are the numbers that are called as the real numbers, right? So you can make a short note like this, that these are those numbers which can be denoted on the number line. These can be denoted on the number line. Then after that, the second, these real numbers. You will not get any question on the imaginary numbers. These are like complex number, root minus 1 or root minus 2. So this is not in our slab. So these are called as the imaginary numbers. Now these real numbers are classified into two parts, which are rational and irrational number, which are going to be your rational numbers. And then after that, the other type is going to be your irrational numbers. Now, what do we understand by this? What are the rational numbers and what are the irrational numbers? Rational numbers are going to be those numbers which can be denoted in the form of, like for an example, if I'm saying 2.3, if I'm saying 3 by 5, right? If I'm saying 5 by 9, these are what? If I'm saying 7.3, these are what? These are the example of rational numbers which can be denoted in the form of P divided by Q. These are the rational number. These are the example of rational numbers. Now, what are the irrational numbers? It also covers, like for an example, 3, 5, 9. All of that. These are what? These are the rational numbers. These are the examples of rational numbers. When I'm talking about irrational numbers are going to be those numbers which has no end. For an example, if I'm writing the value of pi, that is 3.14 and it will goes on. There is no end to it. That means these. You asking something, Bharat? No. Okay, so we are going to discuss about this rational numbers. So these are the examples of the rational number. When I'm going to talk about the irrational numbers, so irrational numbers are those numbers which is having no end. For pi, pi is what? If I'm talking about pi, the value for pi is going to be 3.14 and then it will go on. There is no end to it. So these are the examples of irrational number. We also don't need to understand this in detail. We only need to understand these rational numbers. These rational number will further classify into three parts. These are going to be what? These are going to be your integers. Then after that your fractions. Then after that your decimals. Now this is something which is important to understand. Now decimals we already know 2.3, 5.9, 7.6. These are what? These are the example of decimals. Fraction are what? Which can be written in the form of P by Q. Which can be denoted in this format. Or will be an example of fractions. Now, when I'm talking about integers, integers are what? Integers are an example of where there is no base, where there is, like for an example, if I'm saying 1, 2, 3, 4. These are what? These are the examples of integers 0, -1, -2, -3. So, if I'm going to talk about the definition of integers, so integers are further divided into three parts. They will be what? Positive integers, negative integers, and then after that, the third part is going to be your zero. So the summary is what? This is how the number line look like. These numbers will be divided into two parts, real numbers, imaginary numbers. Real numbers will be those numbers which can be denoted on the number line. Then after that, if I'm going to rational numbers which is having certain end, right? If you are going to simplify this, you'll be finding that there is a end, right? For an example, 0.39, there is an end to it. But if I'm saying 3.1497321, if this is a continuous process, then that will be an example of irrational number. That will be an example of irrational number. Then after that, these rational numbers are divided into three parts, which are going to be your integers. Then after that, your fraction, and then after that, your decimals. Now here comes the story of prime numbers, composite numbers, even numbers, and odd numbers. Now that is the most important part. You will not be getting questions on these classification, but the question that is asked in the exam can be based on this classification, this integers. Now, if I'm going to talk about these integers will be divided into different parts that we are going to understand. The one is going to be a whole numbers. Now, are you guys aware of in whole numbers what are the numbers that are included? Can you guys let me know in the chat box what will be included in the whole numbers, and then after that what will be included in the natural numbers? Then after that your prime numbers, and then after that your composite numbers. 0 to infinity. Correct. Okay, all right. So you guys are aware of this. Now, when I'm going to talk about whole number, that means it will start from 0, 1, 2, 3 till infinity, right? These will be an example of whole numbers. Now, when I'm talking about these natural numbers are what? When you are excluding 0. So 1, 2, 3 till infinity. This is what? This is an example of natural numbers. Now, let me know what are the prime and composite numbers. Prime numbers are those that have a factor of 1 and the number itself, and composite are those which are having the numbers other than 1 and itself. Correct. So if I'm going to talk about prime numbers, so prime numbers are those numbers which are having factors, they are divisible by themselves and another number. right? For an example, let me know what will be the first prime number on the number 9. 2, correct. Now, if I'm going to talk about prime numbers, what will be these? 2, 3, 5, 7, 11, 13, 19, like this. So these are what? 2 is only divisible by 2 and 2 is only divisible by 1. That means a number which is having only two, what? Which is only divisible by two numbers will be what? It is going to be a prime number. 2 is divisible by only 2 and 1. 2, 3, 5, 7, 11, 13, 19. Now, the composite numbers. Now, what is going to be composite numbers? Composite numbers are those numbers which are divisible by themselves as well as 1 as well as from the any other factor of it. Like for an example, the 4. Then after that, your 6. Then after that, 8. Then after that, 9. Then after that, 12. Then after that, 14. So in this case, if somebody asks you what is the first odd composite number, so the answer here is going to be what? 9. On the number line, what is the first odd composite number? So the answer is going to be 9. So here the difference is what? Composite numbers will be 4, 6, 8, 9, 12, and 14. Prime numbers are 2, 3, 5, 7, 11, 13, and 19. So this is the classification of prime numbers and composite numbers. Now, when I'm going to talk about 1 is neither a prime number nor it is a composite number. So if I'm going to talk about 1 is not a prime number, not a composite number. So this is the classification: prime numbers and composite numbers. Now, what kind of question can be framed on it? The kind of question that will be framed on it can be based on, like for an example, there is a even numbers. There are certain three even consecutive numbers are there. So if the first number is x, the other one will take x plus 2, then the third one will take x plus 4. Like this will be taking. Na? There should be a difference of 2. There should be a difference of 2. These are what? These are the example of consecutive odd numbers or the consecutive even numbers, right? So this base, I think we are all are aware of. Now, the second type of question that will be getting from it. Now, suppose they have given a number and they will be asking, is it a prime number or it is not a prime number? So how we are going to check it? The type of question that will be getting is, suppose there is a random number that is given 3, 4, 7. Now, is it a prime number or is it a composite number? So how we are going to find it? So the logic here is that all the prime numbers will be in the format of 6n plus minus 1. All the numbers which are what? Which are prime number will be in this pattern: 6n plus minus 1, except what? Except your 2 and 3. 2 and 3 does not follow this rule. All the remaining numbers are in this format: 6n plus minus 1. Now, for an example, if I'm going to take n is equal to 1, so this will be giving what? 6 into 1 plus 1 minus 1, right? So you'll be getting 5 and 7. Once you're going to add it, you'll be getting 7. Once you're going to subtract it, you'll be getting 5. 5 and 7 both are what? Both are the prime numbers. Now, for an example, if I'm going to take 2 here, it will be what? 6 into 2, 11. 11 plus 1, 13. 11 minus 1, 12 minus 1, 11. So 11 and 13 both are what? Prime numbers. So the outcome here is that all the prime numbers will be following what? All the prime numbers will be following this rule. All the prime numbers will be following 6n plus minus 1 rule. But for each and every value of n, this is not true. I hope you guys understand what I'm saying. Like for an example, if I'm saying I'm taking n is equal to 4. So if I'm going to multiply 6 into 4 plus 1 minus 1, now you know that this will be giving 24. 24 plus 1 is 25 and 25 is not a prime number. 25 is not a prime number. So that means what I'm trying to say is all the prime numbers will be in this format. For each and every value, it will not give prime number. Let me know how many of you are able to understand. That means all the prime numbers. How we are going to check, is it a prime number or it is a composite number? We will divide the given number by 6. If we are getting remainder 1 or we are getting remainder minus 1, that means it is a prime number, or else it is not a prime number. That is one way of checking it. That means all the prime numbers will be in this format: 6n plus minus 1. But for each and every value of n, this may be correct, this may not be correct. Is it clear? Have you guys done it before? All right. All right. So this is what, this is an example of, like, if a number is given, they'll be asking, is it a prime number or is it not a prime number? Okay. So they'll be asking, is it a prime number or is it not a prime number? So that is how we will be getting the answer. Now the second part is going to be unit digit. Finding the unit digit. This is the first part, classification of number. Now the second part is going to be unit digit. Now suppose you are going to multiply two numbers. For an example, let's talk about addition. Now if I'm going to add something, if I'm going to talk about addition, for an example, 4, 9, 3, 2, 1, 7, 3, 2, 9, 7. Then after that 5, 3, 9, 2, 11, like this. If I'm going to add these numbers, and if we need to find out unit digit, it's very easy. What do we mean by unit digit? That means the digit that is coming at the unit place. So if in this case, if you are going to add this, what is going to be the unit is 7 and 1, 8 and 1, 9. We know that what will be the unit digit. We don't need to understand on the addition and the subtraction. The same logic applies on the both the cases. Now, if I'm going to talk about 3, 4, 9, 7, 1, 2 multiplied by 5, 7, 3, 2, 9, what will be the unit digit in this case? Can you guys let me know in the chat box? What will be the unit digit in this multiplication? All right, we are going to understand it now. Yeah, 8 is the unit digit. So in case the kind of question we'll be getting on the number system on unit digit means what? If you are going to multiply this number by this number, what will be the number that will be coming at the unit digit? So we don't need to multiply this whole number. What we'll be doing is we will multiply only these numbers which are coming at the unit place. We will multiply by this 2 by this 9. What we are getting? We are getting 18. 18, right? So we'll be keeping 8. 8 will be at the unit place. We don't need to multiply all these numbers. This is the concept of unit digit. Now, for an example, now if I'm going to multiply 7, 3, 2, 9 into 1, 8, 7, 3. Now, what is the unit digit here? Now, I don't need to multiply the whole fraction. I will multiply only 9 and 3. I'll be getting 27. So 7 will be at the unit place. So these are the type of question that will be asked on the unit digit. That means they'll be asking, if we are going to multiply these two fractions, what number will come at the unit place? So we don't need to multiply all these fractions that are there. We will only be multiplying the unit places and we will be able to find the answer in these cases. So in case of, you know that in case of subtraction, what will be the unit is? We are aware of. Now in these cases, if you are going to multiply these two numbers, what will be coming at the unit place? That is what we need to find out. Now in some cases, for an example, now if I am going to write 2 to the power 5 into 5 to the power 7 into 9 to the power 18 into 5 to the power 16. Now, in this case, if I need to find out what will be the unit digit, so try to understand. These are the basic rules. If 1, 2 will be multiplied by 1, 5, you will be getting 0, right? You'll be getting 10. So that means if in any kind of multiplication you get 1, 2 and 1, 5, that means the unit digit is going to be 0. If you are going to multiply any number by 10, you know that you'll be getting a 0. 3 multiplied by 10 will be giving you 30. 300 multiplied by 100 will be giving you 3000. In all these cases, what will be there? In all these cases, the unit digit is going to be 0. Right? So, in case of unit digit, if any sort of multiplication is given, we don't need to multiply all the numbers that are there. We will be only multiplying the numbers at the unit places, and that is how we will be finding the unit digit in all these cases. Okay, so we are only doing all of this in a very quick manner. And once I complete this number system, we will quickly summarize all those things. Just be there in the class and have some patience. All right. Now the second part that I forgot to mention on the first slide, these are what? These are the example of classification of numbers. And then after that, when I was talking about this part, here we'll be talking about the classification of number, unit digit. And the third thing, which is really important, is going to be divisibility. Now, what do we mean by divisibility? Now, for an example, if I am saying there is a number that is given like this 917321. Now, if I'm asking, is this number is divisible by 3 or not? Is this number is divisible by 4 or not? If this number is divisible by 5 or not? Guys, let me know in the chat box. Have you done question like these before? Have you done concept like this? or you are doing it for the first time? You have done divisibility, right? Do let me know, all of you. I'm just asking so that I could have an idea about it. Like, what should be the difficulty level I should keep? In recent times, you haven't done. Okay. So that is why I'm asking. So when I'm talking about divisibility, divisibility means what? We need to find out this given number is divisible by 3 or not. If this given number is divisible by 2 or not. So there are certain rules through which we can find it out. Now, for an example, if I'm going to talk about divisibility rule for all these numbers, just try to understand. Now, if I'm going to talk divisibility rule for 2, which number will be divisible by 2? Divisibility for 2. Now, you know that divisibility rule for 2 is what? If no matter what number is given, 2, 1, 7, 3, 2, 9, 8, if the unit place, if the unit place is divisible by 2, the whole number will be divisible by 2. Correct. If at the unit place you are getting an even number, if the unit place is divisible by 2, that means the complete number is divisible by 2. That is the divisibility rule for 2. Here, what is happening? Here, in this case, this place, this number at the unit place is divisible by 2, the whole number is divisible by 2. Then, after that, the second example, 259,215,790. Here, this unit place is 0. 0 is an even number. It is divisible by 2. That means the whole fraction is going to be divisible by 2. That is the divisibility rule for 2. Now, if I'm going to talk about divisibility for 4, divisibility for 4. Now, for an example, what I'm saying is 428 is a number. Now, if I'm asking, is it a just let's take the another number. Like for an example, we are taking 928. Now, if I'm saying, is it divisible by 4 or not? Divisibility for 2 we have done, divisibility for 4. Now, if we are going to divide this number by 4, is it completely divisible by 4 or not? We are going to simply divide it by 4. Now, in this case, the rule is that if we need to check the divisibility for 2, we will divide the unit digit by 2 and we'll check it. Now, if in case you are finding out divisibility for 4, we will divide the last 2 digit by 4, and if the last 2 digit of a number is divisible by 4, the whole number will be divisible by 4. Now, how to use it? Now, for an example, if I am saying 4197235 then after that 48. Now, if I am asking, is this number is divisible by 4? Right. Last 2 digit of the number. Now, here in this case, if I need to find out is it divisible by 4 or not, so I am not going to completely divide it. I will only divide the last 2 digit of this number. And if the last 2 digit of the number are divisible by 4, that means the complete number will be divisible by 4. So the rule is completely same. For 2, you need to divide last digit by 2. Right. Now, in the second case, if the last 2 digits are divisible by 2, this number will be divisible by 8. Now, for divisibility by 8, what we need to check? Last 3 digits. If the last 3 digits are divisible by 8, that means the complete number will be divisible by 8. So, we don't need to completely divide the complete number. We will only by this rule we can find it out, is it divisible by 2, 4 and 8. So, this goes on similar like for 16, last 4 digits. So, this is for 2, 4, and then after that your 8, and then after that your all right. So when I'm talking about this rule, divisibility for 2, last one digit. Divisibility for 2 की power 2, that means you will divide the last 2 digit by 2. 2 की power 3, that means 8, you will divide the last 3 digit of a number by 8. If it is completely divisible by the last 3 digits are divisible by 8, that means the complete number will be divisible by 8. Now this is about the divisibility of 2, 4, 8, 16. This will go on like this. Now for an example, now, if we are going to understand the divisibility for 3 and 9, now we are going to understand about 3 and 9. Sum of the digits. Correct. Sum of the individual number is equal to correct, 100%. Now, in case we are finding if a given number is divisible by 3 or if a given number is divisible by 9, whatever number is given, for an example, 2, 1, 3, 9, 7, 2. Now, is this number divisible by 3? What we'll do? We will add the digits of the number. If the digits of the number. If the sum is divisible by 3, the whole number will be divisible by 3. What we are going to do? 2 plus 1, 3. This 3 is divisible, 9 is divisible, 7 plus 2, 9. That means the complete number is divisible by 3. Even we don't need to add. What we'll be doing? We will make the pair, we will make the pair of 3 and we will divide them, and that is how we can find it out. Like for an example, 2, 1, 7, 2, 9, 3, 2, 1, 5, or then after that 4. Now, is this number is divisible by 3 or not? How we are going to find it out? 2 plus 1, 3. 3 is divisible. 7 plus 2, 9 is divisible. 9 is divisible. 2 is divisible. 2, 1, 3 is divisible. 5, 4, 9 is divisible. This whole number is divisible by 3. That means for that, if you want to check the complete number is divisible by 3 or not, what we'll do? We will just add the number. If the number are divisible by 3, the whole number will be divisible. And this rule is same for 9 also. For an example, now I'm saying 9, 1, 8, 3, 5, 9. Now this number is divisible by 9 or not? What I will do? I will add all these numbers. If the sum of the number is divisible by 9, the complete number will be divisible by 9. Now here also I am not going to add it. This 9 is divisible by 9. This 8 plus 1, 9 is divisible by 9. This 3 and 5. That will be what? 8. 8, this 9 is divisible. For I'm just keeping it 1 here. So 3 and 5 will be 8. 8 and 1, 9. So the complete number will be divisible by 9. So that is the divisibility rule for 9. So for 3, add all these numbers. For 9, add all these numbers. Sum should be divisible. So you can make a note of it. 2 for 2 and for 9. So we have done how to find out the divisibility for 2 is there. Then after that 3. Then after that 4. Right? Then after that your 8. And then after that your 9. Right? What is left here? 5, 6. And then after that your 7. Right? 5, 6, 7. Now for 5, 6 and 7, what is going to be the divisibility rule? Now for 5, if the unit digit, is 0 or 5, if the unit digit is 0 or 5, the whole number will be divisible by 5. If at the unit place you are getting 0 or at the unit place you are getting 5, the complete number will be divisible by 5. That is divisibility for 5. Right? So this is what this is about divisibility, how we find out. Now, what can be the other examples? Now, for an example, now if I'm going to talk about divisibility for 6. Now, for 6, the divisibility is what? You will check if the numbers are divisible by 2 and 3. You will add the numbers and you will check is it divisible by 3. You will check the divisibility rule of 2. If both follows, that is the number is divisible by 6. If the number is multiples of 2 and 3, then divisible by correct, correct, correct. So that is the divisibility rule for 6. What is the divisibility rule for 7? For 7, whatever number is given. For an example, 1, 4, 9, 7, 2. So we will multiply the unit digit by 2 and we will subtract it. And then after that, if this subtraction is divisible by 7, then the complete number will be divisible by 7. Now, what can be the examples of it? Now, for an example, if I'm taking 3, 4, 3, right? I'm taking an example of 3, 4, 3. Now, what I'll do here is I will multiply the unit digit. I will multiply the unit digit by 2. I'm going to multiply the unit digit by 2. It will be giving 6, right? And from the remaining number, I will subtract this 6. What I'll be getting? I'll be getting 28. This 28 is divisible by 7. The complete number is divisible by 7. That is the divisibility rule. Correct, correct. Unit digit will be multiplied by 2, will be subtracted from the remaining digits. And if the subtraction is divisible by 7, the number will be divisible by 7. Same goes for 11. Not same goes for 11. In case of divisibility for 11, 1, 2, 3, 4. For an example, 1, 5. Then after that, 1, 5. Now here in this case, what we need to find out? Here in this case, if you are going to add the numbers at the alternate place and if their subtraction, if you are going to subtract these numbers, if you are getting 0 or you are getting a multiple of 11, then in that case the complete number will be divisible by 11 or else it will not be. Now, what can be the example of it? We are going to understand by example 1, 3, 3, 1. Now you know that if you are going to add this number, you'll be getting 3 plus 1 numbers at the alternate place. 3 plus 1 will be getting 4. Now, if you are going to subtract 4 and 4, you'll be getting 0. So, if you are going to add the digits at the alternate places And if you are going to subtract them, if you are getting 0, that means what? That means it is an example of a number that is divisible by 11. Or if you are getting a number that is equal to 11 or the multiple of 11, in that case, these numbers will be divisible by 11 or else they will not be divisible by 11. So this is the discussion that was about the divisibility, right? So divisibility, if you will be keeping these basic things in mind, there can be many other things. So that is the base of it. That is the foundation of it. Now let's talk about the other parts of it. Now what is left? We have done the divisibility, and then after the what more was there? Remainders, right? Now if I'm going to talk about remainders, now in these kind of cases, in case of remainders, you just need to keep one thing in mind. In case of remainders are what? Remainders are additive in nature, subtractive in nature, divisible in nature, and multiplicative in nature. What do we mean by that? Now, for an example, if I'm going to multiply 7, 7, 7, and if I'm going to divide it by 6, 6, and 6, for an example, or else I can take the another example. For an example, if I'm going to divide it by 6, right? If I'm going to divide it by 6, what will be the remainder in this case? Try to understand. It is multiplicative in nature. That means if I'm going to multiply it and then find the remainder, and if I'm going to find the remainder, then multiply, in both the cases, the answer will be same. If I'm going to divide this 7 by 6, what I'll be getting? I'll be getting remainder 1. Here also 1, here also 1. Now here, if I'm going to multiply it, it will be 749 and it will be 343. Now if I'm going to divide this 343 by 6, what I'll be getting? I'll be getting 43 here, and if I'm going to divide it, it will be 57, and you'll be getting remainder 1 here. So what is happening in this case? In case you are going to divide these numbers, if you are going to multiply it and then divide, you'll be getting remainder. And if you are going to find the remainder and then multiply, still you'll be getting the same remainder. So in these kind of questions, if this sum is given, if this subtraction is given, if the multiplication is given, if the division is given, we need to, you can find out the remainders in each cases, and then after that you can apply these applications. Here, if you are going to multiply, then finding the remainder, in the same thing. So this is about the remainder. In case of addition, you will find the remainders. What are the remainders in each case? Then you will add it. And that is how you can find the answer. This same goes in the multiplication. This same thing goes in the division, right? So this is about our discussion on the remainders. I'm keeping this till here only. There can be so many other things, but we are having limited time. So I'm only having discussion on the concept. Now let's talk about the mensuration. Now here, this is a completely formula based thing. I'll be quickly summarizing the formula that you need to keep in mind in case of mensuration. Now I hope you guys are aware of if this is a square. We are first of all going to talk about the two-dimensional figures. We are going to talk about 2D figures. Now I'll be quickly summarizing the class. In case you'll be having any doubts, you can let me know in the class, because we are going to complete this logical and QA in one class. So that is a difficult task for us. So I'll try to summarize things quickly. In case you'll be having doubt, you can let me know. Now in case of a square, we know that the area is a square. We know that the perimeter is 4a. Now perimeter is what? The length of the side, and the area is this part. In case of a rectangle, we know that if this is L, this is B. The area is going to be L into B, and the perimeter is going to be 2L plus B. Now, in case of what? This is a square, this is triangle. Now, if I'm going to talk about triangle, this is H. For example, this is base. So, what is the area in this case? Now, this is height that is given here. This is base that is given here. For example, these side are A and B. This is perpendicular distance. Now, in case of triangle, what is going to be the area? Area is going to be 1 upon 2 base into height. 1 upon 2 base into height. Now, in case of what will be the perimeter? Perimeter is going to be A plus B plus C. Right? Now, can you guys tell me what can be the other formula for the perimeter of triangle? Not perimeter, for the area of triangle. What are the other formula? Are you guys aware of Heron's formula? Are you guys aware of the formula that we use, like using theta, sine theta? The one thing is 1 upon 2 base into height is one way of calculating the area. Now, in case of equilateral triangle, all sides are going to be A, and A. In this case, if you are going to draw a perpendicular, it is going to divide it into two equal parts. This side is going to be root 3 by 2A. And if I need to find out the area in this case, it is going to be what? 1 upon 2 base is what? Base is going to be A and root 3 by 2. So in this case, root 3 by 4 A square is going to be the area. This is in case of a equilateral triangle. This is in case of a equilateral triangle. Now, this is about the equilateral triangle. Now, in case this is a scalene triangle. Here, this side given A, this side is given B, this side is given C. We need to find out the area in this case. We can use the Heron's formula. That is under root S, S minus A, S minus B, and S minus C, where S is what? This is area of the triangle of an scalene triangle where side are A, B, and C that are given. Now S is what? S is going to be the semi-perimeter. This is going to be semi-perimeter. That is S is equal to A plus B plus C is what? This is perimeter. And if I'm going to divide it by 2, this will be called as what? This will be called as semi-perimeter. Guys, is it clear? This is square, this triangle, and rectangle. Do let me know quickly. It's clear, no? Okay. Okay. Now there is one more thing. For an example, this theta is given. This alpha is given. This is beta that is given here. So now in this case, if two sides are known, if A and B is known, the formula is going to be 1 upon 2 AB sine theta. I hope you can note it down. AB sine theta. For this beta is given and these two sides are given. So I'll write the area is equal to A, this is B, this is C. Na? So AC sine beta. If these two sides are given and this angle is given. These two sides are given, this angle is given. So the formula is going to be 1 upon 2 BC sine alpha. This is also a formula for calculating the area of triangle. So square we have done, rectangle we have done, triangle we have done. Now then after that, this if circle is given, we know that in case of circle, what is going to be the area? If this is radius, the area is going to be pi r square. What is the circumference here? Circumference is going to be 2 pi r. Circumference and perimeter both are the same in case of a circle. So this is about the circle. Then what can be the other things in this part? No, this is a parallelogram. No, this is not a parallelogram, this is a trapezium. If I'm going to talk about the parallelogram, for example, this is a parallelogram. Now here, if this height is given h and this is given b, right? Any of the parallel side is given and the perpendicular distance between these parallel sides is given. So the area is going to be 1 upon 2 bh. Not 1 upon 2 bh. We are going to divide it into two parts. This part area is going to be 1 upon 2 bh. This part area is going to be 1 upon 2 bh. So it will be 1 upon 2 bh, 1 upon 2 bh. The area is bh. That means this height multiplied by this base is the area. How we find out? We will discuss that. This is with respect to how to find area in case of a parallelogram. Now this thing goes same in case of a trapezium. Now in this case, if I need to find out the area in this case, for example, this side is given A, this side is given B, and this side is given H. So the area here is going to be 1 upon 2 sum of the perpendicular side A plus B into perpendicular distance between them, that is H. This is the area in case of a trapezium. Trapezium. This is the area in case of a parallelogram. This is an area in case of a parallelogram. Then after that, there is one more figure that is called as what? That is called as rhombus. Now, in case of rhombus, what is the property? No, rhombus and parallelogram. Rhombus is also a kind of parallelogram. The difference between them is what? Here in parallelogram, the opposite side are parallel and they are equal. Here these opposite side are parallel and they are equal in length. Here these opposite side are parallel and they are equal in length. But here in this case, opposite side are parallel but all the sides are equal. If this side is A, this is A, this is A, this is A. But here this will be A and A, this will be B and B, like this. So here in this case, the diagonals of rhombus bisect each other at the angle of 90 degree. So here in the formula is going to be 1 upon 2 D1, D2, where the D1 and D2 are what? D1 and D2 are the length of the diagonal. D1 and D2 are the what? D1 and D2 are the length of the diagonal. Right? So this is the summary of the two-dimensional figures where we have done discussion on the parallelogram. Then after that, your this is parallelogram, this is trapezium, and this is rhombus, right? So so that is something we have done with respect to two-dimensional figures. Then after that, here comes the three-dimensional figures. So in three-dimensional figures, there are three things that we need to keep in mind. What are these things? Two dimension, we were having discussion on area, and then after that perimeter. Now when I'm going to talk about the second part, that is 3D. In three-dimensional figures, there will be three things that we need to discuss. The one is going to be your volume, then the second one is going to be your surface area, that is curved surface area, and the third thing is going to be your total surface area. So with respect to three-dimensional figures, there are going to be three things that we need to understand. Their volume, their surface area, that is curved surface area, and then after that your total surface area. So we are going to understand what is volume, curved surface area, and total surface area with respect to all the figures that are given in the 3D. So the first figure is looking like this. This is what? For an example, this is a cube. Now cube is what? This side is A, this side is A, this side is A. Now if I'm going to talk about volume in this case, volume of a cube is what? That is going to be A cube. Now this is nothing but the base area multiplied by height. Here the base area is going to be A into A multiplied by perpendicular height. And we got the volume in this case. Now if I'm going to talk about curved surface area. Now what do we understand by curved surface area? If I'm going to talk about this is a cuboid. What is the curved surface area? This area plus this and plus this. This is what? This is an example of curved surface area. If I'll be talking about total surface area, I'll include these surface, top and bottom. So here in this case, the curved surface area will be what? This area, this surface area, this surface area, this surface area. So curved surface area is going to be 4a square. If I'm going to talk about total surface area, this is going to be 6a square. Because we are going to include this top area and this bottom area. Right? So with respect to cube, the volume is going to be a cube. The curved surface area is going to be 4a square. The total surface area is going to be 6a square. Now, if in the same case, we are going to understand the cuboid. Cuboid is similar to this figure. Cuboid is similar to this figure. This is L, and for example, this is H, and this is B. Right? This breadth is given. Now, in this case, what will be the volume? This is nothing but base area, that is L into B, surface like base area multiplied by height is what is volume. Now if I'm going to talk about the curved surface area, now curved surface area will be again similar to the previous one. Area of this surface, that is what? That is L into H. L into H. Now here this surface which is in front of the figure, and there is a figure that is on the back. There is one surface that is on the back side. So this 2LH is there plus this side. Here you know that this base is B and this is H. So BH and BH, 2BH. So here in this case, what we are getting? This is what? Curved surface area. We don't need to remember any of these things. You will be easily able to formulate these. You can take 2H common here, 2HL plus B. 2HL plus B. Then after that, the third thing is going to be total surface area. Total surface area include this figure, this surface also. So total surface area will be what? Taking 2 common here, LB plus BH plus HL. That will be giving the total surface area. That will be giving the total surface area in case of a cuboid. Now we have done the discussion on your cuboid. We have done the discussion on the cube, right? Then after that, the second thing, like not second, third thing comes here, that is cone. Now in case of a cone, this is radius, this is height, this is the slant height, that is L. Now in this case, this is a right angle triangle, this is 90 degree. So you know that in 90-degree triangle, we can calculate this slant height L is equal to what? That is equal to under root h square plus r square. So this is slant height. If the height is given, if the radius is given, we can find out what will be the slant height. Now what is the volume here? Volume is going to be 1 upon 3 pi r square h. This is going to be 1 upon 3 pi r square h. That is the volume in case of a cone. Now, if I'm going to talk about the curved surface area, curved surface area means what? Area of this part, area of this part, area of this part, area of this part. So, curved surface area is nothing but pi r l. If I'm going to talk about total surface area, that will be pi r l, area of this surface plus this area also. Because here the area of top is 0, area of bottom is what? It is a circle. So, the area is going to be pi r square. So, this is with respect to cone. What is going to be your volume with respect to cone? What is going to be curved surface area with respect to cone? And what is going to be total surface area with respect to cone? Right? So this is about cone. Then after that, there is one more figure. That is what? That is your cylinder. Now, in case of cylinder, if this is going to be your perpendicular height h and the base radius is r, right? This figure is looking like this. Now volume will be what? Pi r square h. Then after that, if I'm going to talk about the curved surface area, that means area of this part, this part. So the area of curved surface is going to be what? It will be 2 pi rh. 2 pi rh. This 2 pi r and this 2 pi r will be counted h times. That is how it will be 2 pi rh. Now if I'm going to talk about total surface area, this will be 2 pi rh plus 2 pi r square. This pi r square plus this pi r square will give the total surface area, including top and bottom. Guys, let me know, are you able to understand this? If you have done it before, then it's all just a revision. How to find out volume or the curved surface area or the total surface area with respect to cylinder and cone. Do let me know in the chat box. Is it all clear? Is there anything you want to ask? Understood, na? It may feel like it is a recorded class because there are so many concepts that I have to do in one class. No doubt, na? Right. All right. Now this is what? This is with respect to your cone and then after that your cylinder. Now, there are two more figures that we need to talk about. The one is going to be a sphere and the other is going to be a hemisphere. Now, here in this case, this radius is r, this radius is r. This is about hemisphere. And here we are going to talk about this is a sphere. A sphere means it is like a football. This is not a circle, right? This is like a football. We are talking about a sphere. Now, here also, if I'm going to talk about the radius for an example. So now, with respect to this, we need to understand what is volume, what is curved surface area, and what is the total surface area with respect to a sphere. And what is going to be volume, what is going to be curved surface area, and what is going to be total surface area with respect to these figures. Now, they are interrelated. This is what? This is a sphere. And now, if you are going to cut this sphere into two equal parts, it will look like this. Now, this surface is looking like this. This surface is looking like this. We have divided this into two equal parts. We have divided it into two equal parts. So now in this case, the volume is what? 4 by 3 pi r cube. If the radius of a sphere is given, that is r. So this will be 4 by 3 pi. What is the curved surface area? No, this curved surface area is going to be 4 pi r square and the total surface area is going to be 4 pi r square. Both are same in this case. Why is it so? Because here, in case of a football, there is no top, there is no bottom, right? So in curved surface area, we calculate the total area. In case of total surface area, we calculate the total area. So this will be 4 pi r square, 4 pi r square. Now in this case, if I am going to divide this sphere into two equal parts, if I am going to divide it into two equal parts, the volume is going to be half, right? The volume will be half. Initially, it was able to hold, suppose for an example, 10 liter of water. Now it will be only able to hold 5 liter of water. So volume will be half. So here it was 4 by 3 pi r cube. It will be 2 by 3 pi r cube. It will be 2 by 3 pi r cube. What will be the curved surface area? It was 4 pi r square. It will be 2 pi r square. Now let me know what will be the total surface area. Guys, let me know what will be the total surface area in case of a hemisphere. See, in case of a hemisphere, the total surface area will be what? Because I have divided into two equal parts. So here, this area, this curved area is what? This curved area is 2 pi r square. That is half of it. But total surface area include area of this surface also. So area of this surface is what? Area of this surface is what? This area is going to be another pi r square. So 2 pi r square plus pi r square. So the answer is going to be 3 pi r square. This is going to be 3 pi r square. This is going to be correct. Correct. This will be 3 pi r square. 2 pi r square plus pi r square. This will be 3 pi r square because this area will also be counted. This area will also be counted. Right? And this same goes in case of a circle. I'll come on this slide. Okay. I'll share these PDFs in the group where all these formulas are given in a table. So you can revise all these concepts from there. Just have a look on it. Just have a look on it. Now, this is about the sphere. Now, if in case of a circle, you know that what is the area? Pi r square. What is the perimeter? The perimeter is going to be 2 pi r. Right? We know that. Now, if I'm going to divide this circle into two parts, this circle will look like this. Now, what is the area here? Area will be pi r square by 2. But what is the perimeter here? Can you guys tell me what will be the perimeter in this case? This total was 2 pi r. So half of the perimeter will be what? Half of the perimeter will be pi r. Is it right? The perimeter in this case is going to be pi r or not? Now, if I am going to divide the circle into two parts, the area will be half. Initially, the area was pi r square. Now the area is pi r square by 2. But what will be the perimeter? Initially, the perimeter was this only. This total was the perimeter. So the perimeter was 2 pi r. Now the perimeter will be this. Perimeter will be this. So this is what? This is half of this total. So this was 2 pi r ka half. This is what? If I'm going to talk about this part, this is what? This is the half of 2 pi r. So this will be what? This will be pi r plus this is center, this is r, this is 2r. Pi r plus 2r. These are what? These are the application of this part. Right, pi r plus 2r. Correct. So this is what these all things we need to keep in mind with respect to mensuration. Now you can solve the questions that are given here. You will be easily able to do it. This is just a revision of the formula on the mensuration. So what other things can be there? Speed, distance, and time. Try to understand. Speed, distance, and time. Now we know that what is the relation between speed, distance, and time? We know that speed is equal to distance upon time. Speed is equal to distance upon time. Now distance is calculated in kilometer. Time is calculated in hour. So the unit for speed is going to be kilometer per hour. Sometimes distance is calculated in meter. Sometimes time is calculated in second. So the unit is going to be meter per second. So sometimes in question you'll be finding that the speed is given in kilometer per hour. Sometimes you'll be finding that the speed is given in meter per second. Right? Sometimes the speed will be given in kilometer per hour. Sometimes the speed will be given in meter per second. So we need to understand. Suppose we need to find the speed and distance is given in meter, time is given in hour. We need to understand the unit conversion. If we want to change, if we want to change kilometer per hour into meter per second, what we will do? We will multiply the fraction by 5 by 18. And if I want to change meter per second to kilometer per hour, I'll multiply the fraction by 18 by 5. Now let me know you guys are aware of this. Why we multiply by 5 by 18 and 18 by 5? We are changing kilometer into meters and we are changing hours into seconds. So 60 into 60. If there is anyone in the class who is not able to understand, do let me know in the chat box. We'll discuss that. Right? So this is with respect to speed. Speed is equal to distance upon time. If you want to, in some cases, when unit conversion is required, you can kilometer per hour multiplied by 5 by 18 will be giving meter per second. Meter per second will be multiplied by 18 by 5 will be giving kilometer per hour. Now, in some cases, now for an example, I am going from place A to B, right? This second type of question that will be getting in a speed, distance, and time will be based on average speed. Will be based on average speed. Now, what do we mean by average speed? How do we calculate average? For an example, there are three units A, B, and C. We will add three units, divide by three. This is called as the average. So, suppose speed 1 is given S1, speed 2 is given S2. Can we find out the average by this? Two speed are given S1 as 2. Can we find the average by adding these two and divide by 2? S1 plus S2 by 2. Can we do that? The second type of question that we get in the speed, distance, and time will be based on average speed. Now, the way how we find out average is nothing but we add the digits. For an example, there is a student who got in one subject 40 marks, in the second one 45, in the third one 50 out of 50. What are the average marks he got? 40 plus 45 plus 50 divided by 3. That is how we find out the average. But this does not work in the speed. Why this does not work? Try to understand the concept of average speed. Now, suppose you start your journey from place A. You are going from place A, you are going by car and you start at the place A and you are going by car. S1 and S2 45. How you are able to say 45? S1 and S2 was that. Now, suppose you are going by car from place A to place B. Now, you are going through a village. You are going through a bumpy road. So here your speed will be very less. For an example, you are going at 10 kilometer per hour. Then suddenly you go on an expressway. Here your speed is 120 kilometer per hour. Then after that, suddenly you enter into a city and there your speed reduced to 60 kilometer per hour. Then after that, again you go on a highway and there your speed goes 80 kilometer per hour. Now, what is the average speed for this total journey? So total, what is the concept of your average speed? What time you have taken to reach this place, right? What time you have taken and what distance you have traveled. That means if we need to find out average speed, this is nothing but total distance divided by total time. Total distance divided by total time. Now, how do we are doing that? It's also very basic. Now, for an example, this is a 30 meter distance, 30 kilometer distance. The first 15 kilometers, I am going at what speed? 45 kilometer per hour. And another, I am going at 60 kilometer per hour. Now, somebody asks, what is the average speed of the journey? Some part, half of the journey, I am going at 45. Half of the journey, I am going at 60. What is the average speed in this case? What is the average speed in this case? So how we are going to find it? What is the total distance that you are going to travel? Is 30 total distance divided by total time. What time you have taken from this place to this place? You know that speed is equal to distance upon time. Time is equal to distance upon speed. Distance is what? 15. This 15 you are going at what is speed? 45. Another 15 at what speed? 60. So this will be like this: 15 upon 45 plus 15 upon 60. Once you're going to simplify it, you'll be getting the answer. So in this is a universal formula to calculate the average speed, total distance divided by total time. Total distance divided by total time. But in these kind of questions, where the distance traveled by you is same. In the first part, you are covering 15. In the second part, you are covering 15. That means here you can use a formula that is 2s1 s2 divided by s1 plus s2. This is what? This is S average. Average speed can be calculated by this formula 2s1 s2 divided by s1 plus s2. But this formula is only and only applicable then when the distance of the two places that you are covering are equal. From this, you covered 15 kilometer. Here you covered 15 kilometer. In some kind of question, you'll be getting you have covered half the distance at this speed, another half at this speed. There is no discussion on the distance. So in that case also we can find out the answer. Suppose for an example, I have covered the half distance at 80 kilometer per hour, another half at 120 kilometer per hour. What is my average speed? So the answer is going to be 2s1 s2 divided by s1 plus s2, 200. This will be 0, 0 balance 96 kilometer per hour. So this is how quickly we find out the answer. In case we need to find out the average speed when the distance of these two cases are similar. But this is only applicable when the distance is similar. If the distance is not similar, total distance divided by total time. This is about the average speed. Now the third part comes here that we need to understand is relative speed. But before that, is there any confusion in the average speed? Is there any confusion in the unit conversion from meter per second to kilometer per hour to meter per second? In case there is any, we can discuss that. Relative speed is what? Now, for an example, I'm Mr. A. I am running, I am running behind Mr. B. Mr. B is going at what speed? 10 kilometer per hour. And I am going at what speed? I am going to at 15 kilometer per hour. When I'm saying I am running at a speed of 15 kilometer per hour, that means my speed with respect to what? With respect to standing object is 15. But here both are running. Both are running in the same direction. Now, if I am running in the same direction, he is going at 10, he is going at 5. So what is the speed of A with respect to B? Now, speed is what? Speed is nothing but what distance you have traveled in 1 hour. Right? So if I start general case, there is a man who will start his run from this place. Now, in 1 kilometer, in 1 hour, he goes 60 kilometer and he reach at this place. So, what is the distance? What is the displacement? 60 kilometer. In what time? In 1 hour. So, the speed is what? 60 kilometer per hour. Now, the second case will be what? What is the speed of Mr. A with respect to Mr. B? Let's take an example of 1 hour. Mr. B in 1 hour will go what distance? He will go 10 kilometer. Mr. B A will go what? He will go 15. That means he will go 15. Right? So what is the distance between them? 5 kilometer. That means if he is going at 15 speed, he is going at 10. So what is the displacement between them? This is 5 kilometer per hour. So in these cases, there are two examples. In case of relative speed, try to understand what are those. If two persons are coming to each other from different points, he is coming at 60 kilometer per hour, another is coming at 50 kilometer per hour. Now you know that in 1 hour, what distance they will cover? In 1 hour, he will cover 60 kilometer. In 1 hour, he will cover 50 kilometer. So what distance they have traveled with respect to each other? They have covered a distance of 110 kilometer. So their relative speed will be 110 kilometer. But now if they are going in the same direction, the relative speed will be 10 kilometer per hour. This is the concept of relative speed. Do let me know, is it clear to all of you? Do I need to explain it again, this concept of relative speed? It's clear, na? All right. Now, what type of question you'll be getting? Now, suppose there is a thief which is spotted by a policeman at a distance of 500 meter. As soon as the thief find out that policeman has saw him, so he start running. He is running at what speed? 10 kilometer per hour. Police officer is running behind him at what speed? 15 kilometer per hour. Not 15, 12 kilometer per hour. Now, if I ask you, in what time the police officer will able to catch the thief? Now, in these kind of question, how to solve it? The distance between them is what? 500 meter. The relative speed between them is what? He is going at 10, he is going at 12. They are going in the same direction. The relative speed will be 2 kilometer per hour. So 2. But this is meter. We will change it into meter per second. Multiplied by 5 by 18. It will be 9. 9 will go here. And 5 will be balanced 900. 900 seconds. After 900 seconds, the policeman will be able to catch the thief. So this is the application of those type of question which can be solved on the concept of relative speed, right? This is one example. The second example is what? The question is what? In what time the policeman will be able to catch the thief in? How we can solve it? By using the concept of relative speed. Now, suppose it says what distance he will run, what distance policeman will run. So there is a formula for the same. If we need to find out distance, it will be delta d a on a minus. Although this is nothing but this is the relative speed, this is the distance between them, and this is the speed. But if you are able to understand the concept, you don't need to learn any of the formula. So that is the discussion on the speed, distance, and time. What are the things that we need to keep in mind? Relative speed, average speed, and then after that, your relative speed, average speed, and the normal speed. And there can be application-based question that can be asked in each and every part. So we have done till now your mensuration, we have done. Then after that, what you have done? Your number system, we have done. Then after that, mensuration is done, number system is done, speed distance is done. There is one more thing is percentage. Now we are going to talk about percentage. Now percentage is something which is really important for the exam because in each and every question you can expect at least two questions. Calculation again. What calculation are you talking about? Are you talking about this calculation? Okay, okay. So here what I said is there is a policeman, there is a thief. And policeman spot the thief at what distance? He spot him at a distance of 500 meters. This is meter. He is running at 10. He is running at 12. This is kilometer per hour and this is kilometer per hour. So we need to find out in what time this person will catch this person. So what is the distance between them? 5 meter. So we know that speed is equal to distance upon time. So here what distance he need to cover with respect to him? The speed, the distance that he need to cover with respect to him is 500 meter, right? Divided by the speed. Now we need to calculate the speed of this person with respect to this person. So this is relative speed. When they are running in the same direction, it's one difference is 2. So here the relative speed is 2 kilometer per hour. So 2 is the given. Now this is kilometer per hour. We want to change it into meter per second. So we will multiply it by 5 by 18. So if I'm going to simplify, it, we'll be getting 9 here. And this will 9 in the denominator will go here. And this 5 and 5 simplified, we'll be getting answer as 900 seconds. This is seconds. Maybe you'll be getting answer in the minutes or hours. Is it clear now how we have done this calculation? If running in the opposite direction, what will be the case? Now, for an example, if they both are running in the opposite direction, first of all, there can be no question on it in case of chasing. In case of police and thief, why will he will be running to the policeman? But it can be asked in the differences. For an example, Mr. A is coming at what speed? 10 kilometer per hour. 10 kilometer per hour. Mr. B is coming at 15 kilometer per hour. And the distance between them is what? For an example, the distance between them is 400 kilometers. Right? At what time they will meet? Now you can understand this is a policeman, this is a thief. Two friends are coming to meet each other. They are running in the same track. One is going at 10 kilometer per hour, other one is coming at 15 kilometer per hour. In what time he'll be able to they will meet? कितने समय बाद वो मिलेंगे? So you know that the distance is 400 kilometers. Speed is equal to distance upon time. Distance is what? 400. Speed is what? They are coming in the opposite direction. So speed will add 15 and 10. 15 and 10 will be what? 25. This is 25 kilometer per hour. And this is 400 kilometer. This is hour. Right? You will find this time in hours. So time will be what? Time is going to be equal to 400 divided by 25. That will be getting 16 hours. So they will meet after 16 hours. So where the 16 hour is coming from? In 1 hour, he'll go 10 kilometer. He'll go 15. Total what the distance covered, they have covered 25 kilometers. 25 kilometers in 1 hour. In 16 hours, they will cover 400. So this is with respect to when they are coming in the opposite direction. This is the concept of relative speed. Right? This is about the relative speed. In case you guys will say, I will revise the concept towards the end. This is the 2 hours class, but we can extend it as much as possible from my side. Alright. So this is about the speed, distance, and time. Now let's talk about the percentage. Now percentage is something which is really important for the exam point of view. Now percentage is what? Because this covers so many topics. This covers so many topics. I'll be telling you the formula and I'll be telling you the philosophy behind it. Percentage will cover question on the salary. Then after that, your population. Then after that, your marking. Then after that, your consumption. Then after that, your voting. There can be so many other questions that can be asked on it. Then after that, your increase or decrease percentage. Then after that, your error percentage. Then after that, your what can be the other things? There are so many other points that can be there. So these are what? These are the type of question that can be asked only and only on the percentage. Then after that, if I'm going to talk about application of percentage, the profit and loss percentage. Then after that, your discount percentage. Then after that, your rate percentage that covers your simple interest and compound interest. Then after that, majority of the question on data interpretation are the completely an application of percentage. So that is why understanding percentage is really important. But we don't need to learn any of the formula for this, and this. We only need to understand the philosophy of percentage. Just by doing that, we'll be able to solve any of the question on this part. Now, when I'm saying percentage, what do we understand by percentage? Percentage is what? Percentage is nothing but per 100. Calculation, percentage means per 100. So no matter what you have got, suppose you have got 40 out of 50. What is your percentage? Percentage is what? Now, what is the use of percentage? Now, there is a student who got 40 out of 50. There is a student who got 60 out of 100. There is a student who got 70 out of 200. Now, there is a student who got 80 out of 200. Now, who is topper in the class? Now, it depends on the reference also. Na? He has got 40 marks, but out of 50. So, what is his percentage? On 50, he is getting 40. So, on 100, what will he get? He will get 80. 20% is 80%. He is getting on 160. On 100, he is getting 60 marks. That is 60%. Percentage is what? Per 100. What number you have got out of 100? So, this is 60%. And the third one, out of 200, you are getting 70. So, what number you will get out of 100? On 100, you will be getting, if on 200, you are getting 70. That means on 100, you will get half. That is 35. That means the percentage here is 35%. Now, in this case, you are getting out of 240, 80. That means out of 100, you'll be getting half. That is 40%. So, percentage is what? Nothing but any comparison that you are making out of 100 is called as percentage. There is a student. Out of 10, he got 8 marks. What is the percentage? Out of 100, he will get what? He will get 80. 80% is the answer. Now, if I say, in a city, total there are 800 people. Out of that, for example, there are 8,000 people. Number of female that are there in the village are 3,000. What is the percentage of male? Can you guys tell me? What percentage of male are there in the village? Or just for the understanding of concept, I'm making it 4,000. Now let me know what percent. If these are the number of female, what percentage of male are there in the town? 50%, right? 50%. So that is the concept of percentage. That is how we deal with the percentage. So in case of percentage, what type of question can be there? We will talk about it. These all the concept of percentage can be summarized on 3 points. 1, 2, 3. A percentage of B. A is what percent of B? A is what percent? More or less than A. No question of percentage will go beyond the scope of these 3 points. Each and every question can be completely summarized only on these 3 points. A percentage of B, you know that A into B by 100. A is what percentage of B? A by B into 100. A is what percent more or less than B? A plus B divided by B into 100. So the percentage is what? Whatever unit you are calculating will be in the numerator, and the unit on which you are making the comparison will be in the denominator in 200. Suppose you got 14 marks out of what? 50 multiplied by 100. This is what percentage. Suppose there is a student who got 30 out of 50 multiplied by 100. This is percentage. So that means the number that the student got is what percentage of total. The number that the student got is what percentage of the total. So A is what percentage of B? A by B into 100. The marks that you got is what percentage of total is the percentage. So this is the idea. 1, 2, 3. Now what are the application of it? Now if I am saying A is what percentage of more or less than B, the answer is A difference B by B into 100. Now how many formula can be made on this? Now if I am saying what is the profit percentage? Profit percentage will be what? Profit is what? Now, I hope you guys have gone through the profit and loss percentage. In profit and loss percentage, there is cost price, there is selling price, there is, there is profit, there is loss, there is profit percentage and loss percentage. So when I'm talking about profit and loss percentage, that means there will be a cost price, there will be a selling price. Suppose if I'm buying a product at 100, I'm selling it at 105. What profit I'm making here? I'm making a profit of 5 rupees on 100. So profit percentage is nothing but your selling price is what percent more than your cost price. That means selling price minus cost price divided by cost price into 100. Now this is something we don't need to learn. This is what? This is coming from this formula. This is what? Profit divided by cost price into 100. This is what? This is coming from this formula. This is coming from the first formula. Achha. Just give me a second. We will continue this class. Just a second. We are going to discuss the concept of percentage. Then after that, I will quickly summarize your number system. Then after that, I'll be talking about your percentage. Then after that is speed, distance, and time. And then after that, we'll practice questions on all four, right? And we have planned, we like our plan was to complete the logical and QA in only one class. But because of the constraint of time, we will only cover QA in this class and logical reasoning in the other class. We will be practicing question on it in today's class. Now, this profit percentage is what? Your selling price is what percent more than cost price. Now, when I say A is what percent more than B, A is what percent more than B. Try to understand this format. A is what percent more than B. A is what percent more than B. So in all these kind of cases, A difference B divided by B into 100. This is what? This is the format. Whatever coming after that will be in the denominator and the difference will be numerator multiplied by 100 will be there. Now this, if we are finding the formula for profit percentage means what? Selling price is what percent more than cost price. So at the place of selling price, this A is there, this at the B, this cost price is there. Selling price minus cost price divided by cost price into 100. No need to use the formula. No need to learn the formula. Loss percentage. Loss percentage means what? Your cost price is what percentage. See, in the loss percentage, your selling price will be less than cost price. That means your selling price is what percent less than the cost price. So here the formula is going to be cost price minus selling price divided by cost price into. So in case of profit percentage or in case of loss percentage, the comparison is only and only on the cost price. Comparison is always and always on the cost price. Suppose I'm buying a pen at 100. If I will sell this pen at 150, this is a profit situation. If I'm going to sell this pen at 50, I'll be making a loss in this case. But in both the cases, what is happening? In both of these two cases, this is happening on the cost price. So profit percentage or loss percentage will always and always be calculated on the cost price. Where this formula is coming from? On this formula, A minus B divided by B into 100. So if you want to find out profit percentage or loss percentage, in denominator keep cost price, in numerator difference of both multiplied by 100 will always be there whenever we are talking about the percentage. So this is with respect to profit and loss percentage. One more thing is there, discount percentage. Now what do we mean by discount percentage? Discount percentage is nothing but your mark price is there, your selling price is there, your this mark price is extra, that is there, cost price is there. Now we need to understand in case of discount, discount does not mean loss. Discount means discount is given on the mark price. Now for an example, I bought a product at 100. This is what? This is cost price. Now I mark this product at 150. I'm marking this product, the MRP, I have marked it 150. Now I am giving a discount of 20%. I am giving a discount of 20% on it. So if I'm giving a discount of 20%, that will amount to 30 rupees. The final is going to be 120. That means if my cost price is 100, I'm marking up this price by 50%. My mark price is coming to 150. And then after that, I'm giving a discount of 20%. Selling price is 150. This is the profit that I'm making in this transaction. What profit I have made in this case? I have bought the product at 100. I have finally sold it at 120. The profit that I'm making in this case is only and only 20%. These are what? These are the application of percentage. How do we deal with the percentage? Is it clear? Can we move on to some basic level questions so that we can have the understanding of these points? Guys, are you able to understand it? These are the questions. How question will be framed in the discount percentage? How question will be framed in the profit percentage and loss percentage? Then after that, the third part that is there is simple interest and compound interest. If you want to go with the formula, we can write the formula. Profit percentage is nothing but selling price minus cost price divided by cost price into 100. Format is completely same. Loss percentage is nothing but this cost price minus selling price divided by cost price into 100. Discount percentage is what? Your discount percentage will be nothing but mark price minus selling price divided by mark price into 100. This is discount percentage. This is discount percentage. This, and this. That is how we calculate discount. Discount is given on what? Format is completely same. A is what percent more than B. Difference divided by cost price into 100. Difference divided by cost price into 100. Difference divided by mark price into 100 in case. Now, this is about the application of percentage, profit percentage, loss percentage, and discount percentage. Then after that, here comes the another application of percentage, that are simple interest and compound interest. These are also the application of percentage. Now, suppose in a bank you are going to invest 2000 rupees. At what percentage? 10% rate of interest per annum for 3 years. What is the profit? What is the interest that will be getting in this case? So again, an example of percentage. You have deposited in a bank account a rupees 2000 and you are getting an interest of 10% per annum, and you are getting this interest for 3 years. So that means in the first year you'll be getting 10%. In the second year you'll be getting 10%. In the third year you'll be getting 10%. So what total you'll be getting? You'll be getting a total of 30%. So 30% of 2000. 30% of 2000 will be the answer. This is what? This is again an application of percentage. For an example, if I'm talking about compound interest, the difference for that we need to understand the difference between the simple interest and compound interest. Simple interest is what? That will be only and only calculated on the principal amount. But if I'm going to talk about the compound interest is what? Which is calculated on the principal as well as that will accumulate on the interest also. For an example, let's talk about an example. Simple interest and compound interest. This will be crystal clear. Both are the example of percentage only. I have deposited 2000 in a bank account. In the first year, I'm getting 10%, I'll be getting 200. In the second year, I'm getting 10%, I'll be getting 200. In the third year, I'm getting 10%, I'll be getting 200. In the fourth year, I'm getting 10%, I'll be getting 200. This is the only interest I'll be getting each and every year. This is simple interest. Now, for an example, I have deposited in the bank 2000 rupees. In the first year, I'll get an interest of 10%. There is, I got 200 rupees in my bank account. Now what will be happening? Now at the end of first year, I have already deposited 2000 rupees. At the first year, at the end of first year, I got 200 as interest. Now in my bank account, I am having 2200 rupees. Now next year, I'll be getting interest on this. So that will be equal to 220. Now in my bank account, initially there are 2200 already. Now I got an interest of 220. So now in my bank account, the total money that is there is 2420. Now next year I'll be getting an interest of 10%. That will be 242. So that is the difference here. Here each and every year you are getting 200, 200, 200, 200. But here in the first year you got 200. In the second year you got 220. In the third year you got 242. That means your interest is increasing year by year because here you are getting interest on interest also. But all are the application of percentage only. All these examples are the completely an application of percentage. So this is an overview of the class, how to solve questions on the percentage, how to solve question on the number system, how to solve questions on the on these parts. Let's quickly summarize the complete concept. All right, we have done the percentage, we have done the number system, we have done the question on the speed distance time, and we have done the questions on the mensuration. We are going to quickly summarize. Now in number system, what we have done? Unit digit. You know that in multiplication, you will multiply the unit digit and you will be getting the answer. Classification of numbers. The question where it can be framed are going to be your prime numbers and composite numbers. Prime and composite numbers. What are these numbers? We know that these prime numbers will follow a pattern 6n plus minus 1. Prime numbers, that means all the prime numbers except for 2 and 3 will be following this pattern 6n plus minus 1. But for each and every value of n, this is not true. Composite numbers, we know that, which are having three factors. For an example, 4. 4 is divisible by 2, 4 is divisible by 4, 4 is divisible by 1. Which is having three factor is what? Is composite number. Which is having two factor, only two factor are what? Then after that, remainders. We haven't given much time on remainders. Let's understand that. So when I was talking about remainder, I said this is additive in nature. This is multiplicative in nature. This is divisible in nature, and this is subtractive in nature. Now, for an example, if I'm saying 7 plus 7 plus 7 divided by 6. Now, if I am saying what is the remainder in this case? Now, what I will be doing? I will divide. I'm not going to add it. In this case, if I'm going to divide it, I'm getting remainder 1. I'm getting remainder 1. I'm getting remainder 1. Add these three. What is the remainder? Remainder 3 we are getting. Now, add on 3. 7 plus 7 plus 7. 21. 21 divided by 6. 18. 3 times 18. Remainder is 3 also. That means in these kind of questions, remainder is additive in nature. So you don't need to add all the numbers and then divide. You can divide the number and then add the remainders, you'll be getting the same answer. What is happening here? 1, 1, 1. Now, how it can be used? It can be used in the bigger numbers. For an example, 49, 49, 49, and 49. These are just an examples. Now, I'm going to divide it by 6. Now, you know that here in this case, the remainder is going to be 1. Here in this case, remainder is going to be 1. Here is 1, 1. So the total remainder is what? Total remainder is 4. What if I am going to add all these? If we are going to add all these, what will be getting? We'll be getting 96. 96 divided by 6. What will be happening? Just a second. What is happening here? Just a second. What mistake we have made here? It will be 196. Yeah, it will be 196. That is why I thought it will be 196, it will not be 96. Right? So in this case, if you are going to divide, you'll be getting a remainder 4. In this case also we'll be getting a remainder 4. So this is an example of that remainders are additive in nature. Remainders are additive in nature, right? Now for an example, if you are getting 7 here, so you will again divide it by 6. That is how we'll be finding the answer. This is one example of additive in nature. Now if I talk about multiplicative in nature, now what do we mean by multiplicative in nature? 76 into 76 into 76. Now let's take two examples only. 76 into 76. Now, if I am going to divide it by 25, what will be the remainder? Now, if I am going to divide it by, here will be remainder 1 into 1 is the remainder. Now, if I am going to multiply and then divide, what will be the remainder? In that also the remainder will be same. If I am going to multiply it, 76 square, that means 6 into 6, 36, 7 into 7, 49, and 7 into 6, the answer is going to be 6, 7, 9 and 8, 17, and 4 and 1, 5. Even if you are going to divide it by 25, here also you'll be getting remainder as well. That means this is what? Remainders are additive in nature, remainders are multiplicative in nature, remainders are divisible in nature, and remainders are subtractive in nature. Now I hope I am clear with the remainders. Right? In unit digit, you know that you will only multiply the unit digits and you'll be getting the answer. So we have done in very detailed manner. Our system is done. Unit digit is done. Divisibility is also done. Na? For 2, what is the divisibility rule? 3, 4, 5, 6, 7, 8, 9, 10, 11. Till 11, we have done the divisibility rule. Then after that, mensuration, I think mensuration, you can look into these slides. For mensuration, this part is there. No? For two-dimensional figures, what we have done? Area, A square, perimeter 4a, L into B, 2L plus B, 2 1 upon 2 base into height, and this is the perimeter. How we can calculate the area of triangle? These are the way when the theta and corresponding sides are given. Then we can calculate 1 upon 2 base into height is this way we can do it. Or if 3 sides are given, then after that we can use the Heron's formula. Moving ahead, this circle was given. Then after that your parallelogram, trapezium, and this rhombus was given. Right? So these are the ways through which we can summarize this part also. Right? This circle was there. Right? In speed, distance, and time, we have already done it in a very detailed manner. Like what will be the speed, relative speed, and then after that, what will be the average speed? We have already done that. Now let's talk about some questions which can be done on what? Some basic level question on the speed, distance, and time also. Speed, distance, and time. The first type of example will be what? Suppose there is a man who is running at this speed, 50 km per hour. In 4 hours, what distance he will cover? You know that in 1 hour he is going 50 km, in 4 hours, the distance he will cover 200 km. Very basic, speed is equal to distance upon time, so distance is equal to speed into time. We have got the answer. Now, in some cases, you will be finding that. In some cases, you will be finding that there are two persons who are, like for an example, there is a man who is going from place A to place B at what speed? 5 km per hour. In the another case, he is coming at what speed? 6 km per hour. Right? What is the average speed? Now you know that average speed when the distance is same, it will be what? 2 s1 s2 divided by s1 plus s2. 2 into 5 into 6 divided by 5 plus 6 plus 1 s2 divided by s1 plus s2. So once you're gonna do it, you'll be getting the average speed in this case. So this is what? This is an example of average speed. This is an example of average speed. And same goes with the relative speed. When the person are coming in the opposite direction, this will be s1 plus s2. When they are going in the opposite direction, the relative speed will be s1 plus s2. Right? So this is from my side on the QA, where we have done number system, where we have done your mensuration, where we have done the application of percentage, and we have done questions on the speed, distance, and time. In the upcoming class, it was planned that we cover all these things in one class, but that was not possible because there are so many topics in the logical reasoning also. So we'll be dealing with the clock, coding, decoding, order entering, mirror and order image, cutting, folding, rotation, cubes and dice in the upcoming classes. All right. Now, class is still here only. In case you guys are having any doubts from today's class, we can discuss that. Do let me know your doubts if there are any.